Students, welcome to Kukaja classes. Today we will learn about electrical power, energy and the heating effect of the electric current. So starting with the electric power. So as we know that when electric current flows through a conductor, electrical energy is consumed. We say that current has done some work. So the power is defined as the rate of doing electrical work. So electrical power can be given by work done or electrical work done divided by time. So if represented in symbols, power is represented in P, work done we have W and divided by time. The SI unit of power is watt. So watt. So if we 1 watt can be described is 1 watt is the power when the rate of work done is 1 joule per second. And the bigger unit of power is kilowatt. 1 kilowatt is equal to 1000 watts. So as we know that electrical work done as per conservation of energy, the work done is converted into equal amount of electrical energy. So we can write in place of work done here electrical energy. So the rate of consumption of electrical energy is also called the power. So power. So derive the unit formula for the power. So here when the work done by a current I, when it flows for time t under the potential difference V, so we can take the work done by the current is equal to V for volt, I for ampere and T for time. So power is the rate of doing work. So P is equal to W. W here is V into I into time divided by time. Cancelling T upon the numerator and denominator, we get V into I. So we can define that as power. The power can power rating can be calculated by the voltage and product of the voltage and current. So power can, there are other two formulas which we can derive by using the Ohm's law. Here we are replacing I with the V upon R. So we get another formula for power is equal to V square upon R. And when there is a third formula, when we replace I with IR, V with IR, so we get power is equal to I square into R. Here you can say the second formula, the resistance is in power, resistance and power are inversely to each other. It means that high power devices have low resistance and low power devices have high resistance. In for example 100-watt bulb operating on 220 volt has a low resistance as compared to the 40-watt bulb which is operating at the which is operating at 220 volt at the same volt. So this way we calculate we can define power. So now we come to the electrical energy. As I told that the work done by the electrical current is converted into electrical energy. So we can define power is equal to energy by time. So energy can be given as the power into time. So if we measure the power in watts and the time in hours, the energy becomes watt hours. So 1 watt hour we can define as the energy consumed when the electrical appliance operating 1 watt is used for 1 hour. So bigger unit of that is kilowatt hour. The kilowatt hour, this unit we also used for commercial purposes as well, and this is the electrical unit for calculating the electricity bill for used for electrical bills as well costing. So 1 kilowatt hour means the 1 kilowatt for 1 hour. When any device operating 1 kilowatt is run for 1 hour. So when we convert 1 kilowatt into watt, this becomes 1000 watt into for 1 hour, and 1 hour into second, so it becomes 1000 into 60 into 60. So it becomes 1 kilowatt hour is approximately equal to 3.6 into 10 to the power 6 joules. So this is the relation between the kilowatt hour and the joules. Now